let's talk about how to find these matrix inverses. To find a matrix inverse, what you're going to do is create a big long matrix, cut it in half. On the left side of this matrix, you're going to put the matrix you're starting with. On the right side of this matrix, you're going to put the identity matrix. Now here's what you're going to do. We're going to do elimination to get this side to look like the identity matrix. Once this side looks like the identity matrix, whatever matrix is left over here is actually our inverse matrix. So let me show you how that works. Now remember, when we're getting the identity matrix, it's basically finding reduced row echelon form. So to find reduced row echelon form, which we talked about in 6.3, we need to focus on getting the bottom half zeros first. That's the goal. So I need the bottom half zeros first. Once I have the bottom half zeros, then I do the top half zeros. And then the last step is to get ones on the diagonal. So let's focus on getting the bottom half zeros first. So I'm going to take row 1 and row 2. It's the only pair I can work with. And I want to eliminate the first column because that's where I want my 0 to be. I want it to be right there in that first column. And then I'm going to replace row 2 with the answer I get. So I've got this. And I need to eliminate the first column. Right now that first column is not going to eliminate, so I'm going to times that by -2. Don't forget to multiply the whole row by -2. Multiply it all the way across. Now that cancels like I wanted. 4 minus 3 is 1. I get -2 and 1 there. So I'm going to replace row 2 with that answer I just got. So we now have the bottom half zero in place. The next step is to get the top half zero in place. So step 2, we're still going to do with row 1 and row 2, but now I want to eliminate the second column because I want a 0 there, and we're going to replace row 1 with our answer. So let's use this one. Don't use your original matrix. And we want to eliminate the second column. Right now that second column is not going to eliminate. So let's times this bottom row by 2. Make sure we multiply through the whole row. So this becomes a 1. That eliminates to 0. 1 minus 4 is -3. That's a 2. So let's look at what we've got left. I'm replacing row 1 with this answer. Row 2 stays the same. Now, at this point, we would want to divide by whatever we need to get ones on the diagonal. However, we already have positive ones on the diagonal, so we're good to go. So this right here, notice that my identity matrix has flipped places. So now the identity matrix is over here, which means that is my inverse matrix. So we write A inverse equals this. That is my inverse matrix. So that is the basic way we find an inverse of any matrix. Let's practice that again, kind of start to get used to it a little more. We always do it the same process. Put the original on the left side, identity on the right side, get the identity to flip places, and whatever ends up on the right side is your inverse. If you wanted to test this, you're welcome to. You could do this one times this one, and you'll notice you'll get the identity matrix. So let's try example 3. Same thing. Put our matrix on the left, the identity on the right, and now we need to get them to flip places. So step 1, we always work on the zeros on the bottom half first, excuse me. So we're going to do row 1 and row 2. We need to eliminate the first column, so I get that first 0 in place. And we will replace row 2 with our answer. So here we go. Right now, my first column is not going to eliminate, so times that by -3. So we get -3, -6, 0, -3, multiply it all the way through. And, ooh, both of these eliminate, and I get 1, -3. So let's replace row 2 with that like we said we would. Now, at this point, because I have a row of zeros here, we now know that finding the inverse of this matrix is not possible. That is why in the instructions it says if it exists. Once you get a row of zeros, then we can say there is no inverse for matrix A. We can be done. So that's an example of showing you that not all matrices have inverses. And we'll talk about more later why some have inverses and some don't. But as soon as you get that row of 0, you can say there is no inverse for this matrix and move on. If you don't get that row of 0, you keep going until you get the identity matrix to flip places. Now, one last thing I want to talk about in this video. So far, we have only been finding inverses of 2x2s. In the next video, we are going to work on finding an inverse of a 3x3, which is much more difficult and a lot more work. However, there is a really nice shortcut for finding inverses of 2x2s. So here's what I want you to do. This is the 2x2 inverse shortcut. This shortcut only works on 2x2s, period. But this is it. If you want to memorize this and use this shortcut instead of this process, you are more than welcome to, but you can use either one on the test and be perfectly fine. Whether you put it next to the identity matrix and get it to flip, or you memorize this rule and apply this rule. You will get the same answer either way. And let me show you how that works. So I'm going to rewrite our matrix inverse rule. So 2x2 inverse shortcut right up here. So it was this. So basically what we're doing is we're saying this is A, B, C, D. And we're just going to apply this rule to it. So A is 1, D is -3, minus, B is -2, and C is 2. And then we have this matrix. A and D will flip places, so we take A and D and flip them places. B and C stay in the same place, but we make them negative. So I'm going to change the sign on this one to a +2, change the sign on that one to a -2. And let's start to simplify. So this is -3 plus 4. -3 plus 4 is 1. And at this point, it's scalar multiplication. So if this was like 1/2, you would just multiply everything in here by 1/2. If this was a 5, you would multiply everything in here by 5. However, this is just a 1, so we multiply everything in there by 1. And look at that. Same answer. So you can memorize this rule and apply it to get a 2x2 inverse, or you could get the identity to flip places and get the same answer. If you really like memorizing, go for memorizing the rule. If you don't trust your brain to memorize and remember the rule perfectly, just stick with the long way, so then that way you know you aren't going to mess this up with a little negative or something. But remember, this only works for 2x2s. In the next video, we'll talk about what to do for a 3x3 inverse.